I'm Jacob Walls. I'm a developer at Farallon Geographics. I've been there a little under 2 years. And I'm going to give this talk about Arch's application development with Arch's QuerySets. I'm going to talk a little bit about the motivation for this work, the intended use cases, a bit of a compare and contrast with related developments in this area across the Arch's community going back, a good period of time. Give you a little walkthrough of how we're using it in Lingo, which you heard about this morning, to hopefully give you an idea of how much or how little this might be useful to you in your Arch's applications, and then conclude with a kind of status update about where this work is timeline-wise and how you can get involved and provide feedback. So to just set the stage about the problem, all of you who are Arch's developers know that the data belonging to discrete Arch's resource models are commingled. They're in generic tables for resources and tiles. So in practice, this means that interacting with this data efficiently involves mixing in knowledge of the model. Queries, in other words, have to be schema aware. So without a custom front end, that is, if your users just rely on the resource editor that ships with core, you have a match between a totally generic framework, totally generic front end, totally generic application. But when you start doing custom development against specific models, it's almost inevitable to maintain some sort of on-the-fly mapping back to semantic identifiers, like names or aliases of nodes, at the moment of querying or saving. This comes up all the time when creating custom APIs and custom front ends for projects. So here's a snippet from Arches for Science. I've worked on this project myself. I'm not suggesting anything here is ill-conceived. I'm just showing it as a snapshot of the kinds of on-the-fly mappings that project developers find themselves having to maintain most of the time. At the top of this post view, you see that there's basically hard-coded constants to maintain that, on-the-fly mapping. Those immediately then get used in the sort of on-the-fly definition of what keys are expected in the post body. So there's a sort of on-the-fly definition of the API representation. And you can see how this, for even a simple model, can start to become verbose and increase the surface area for omissions. If I were to keep going, I've kind of simplified these basic views in Arches for Science down to like their major tasks. First major task is to parse that API, parse that shape with a semantic key. So instead of parsing a verbose UUID, parsing the string sample description, then that ellipsis would probably take up some more space. Then reshaping the incoming data, for instance, to make it conform to a template. So accepting just a sample name, but reformatting it as a standard sample name with more information. Also allowing a slimmer interchange format. For instance, you might be interested in just sending a single string over the wire instead of a localized string blob with 7 or 8 values when all you really cared about was a single value. So often a custom view will just, define its own slimmer interchange format. And then finally, this view is also selectively re-indexing related resources. And you can generalize from this. Often a custom view needs to orchestrate specific side effects. These are the 4 major things that this view is doing. Okay, this is all well and good, but with a custom view like that, at the project level, you're taking responsibility for maintaining a bespoke data access layer. So everything I just described as a benefit certainly is a benefit for Arches for Science, but what that means is that it has to be discovered in Arches for Science, re-implemented in Arches for Science, tested in Arches for Science without error. Okay, that was one view. Arches for Science has other views. And wait, there are more use cases too. We need to sort stuff. Cards, nodes, tiles, all kinds of things need to be sorted. There's some attention needs to be paid to efficient interaction with the database, prefetching all the related records that go with the records that you're interested in. Sometimes there are delicate, finicky ways to express that in Django that, again, have to be rediscovered and re-implemented without error. There's all sorts of Arches subtleties. Which nodes have node groups? For instance, pop quiz, did you know that top nodes didn't have node groups? Graph versions are coming in version 8. Adds another layer of complexity to interacting with nodes and graphs. I've already mentioned database performance, but you need to scrub your views to make sure you haven't accidentally scanned the whole tiles table. We've already touched on reusability. Where do you validate? How do you decide which part of your data access layer is responsible for validation? Is it the perimeter? Is it the top of your view? You're constantly confronting these questions about where to place the responsibility for validation. Transforming and internationalizing error messages, right? You want a well-behaved JSON API shouldn't accidentally return some HTML from the default Django view. Errors need to be localized when that's appropriate. Too much information shouldn't be exposed, right? Because that's a security vulnerability if you've accidentally included a traceback in your error message. And some of these things, and I've already mentioned, would be useful in other places besides views, right? Management commands, migrations, etc. Wouldn't it be nice to use named node and node group aliases all over your stack? And so on. So that was the inspiration for this work, which was to try to generalize and sort of reduce the surface area for omissions and sort of delegate these aspects of data fetching to well, right now it's an Arches application that we're calling Arches QuerySets, so that Arches application, Rob has already called attention to this ambiguity earlier today. There are certain kinds of Arches applications that are generic and other sorts of Arches applications which represent specific projects. And so what we're interested in is creating a generic flavor of an Arches application that makes development for projects easier. And that's what we're using in Arches lingo. So I've already mentioned, in the sort of riffing on the Arches for Science API, how this would be useful for project level APIs, but you could also imagine this same interface being useful for writing tile functions. Data migrations, as I just mentioned, management commands. I know we've got fans in the room, such as Galen, who like management commands, interactive notebooks, and so on. So the idea is to sort of push low-level tile transformations out of projects and just deal with resources, either in whole or in part. For instance, halfway down a resource, tiles from that node group down, something that's flexible enough, to both deal with a single tile, a group of tiles, or an entire resource. I guess I would draw an analogy to the way Django itself in the Django ORM abstracts away details like constructing joins to let users focus on traversing relationships between model fields. The idea of this work is to abstract away tile lookups to let users focus on interacting with their Arches models in that same way from field to field, like by named node groups and nodes. I think, yes, that's may have foreshadowed this slightly, but I'm still going to go through this slide. All we've done is encapsulate at that layer aliasing under node and node group aliases. The one trick was just to avoid creating new database entities. So the current implementation doesn't deploy additional views to back this up or additional tables. It just preserves information that's provided at the time of querying to assist with saving the data back. So if you're at the beginning of my presentation, I mentioned that basically effective querying of Arches data requires doing a schema-aware query. The idea is to just save that information at the moment of querying to assist with untransforming the data back into the tiles table. And we've paid some attention to persisting in bulk as much as possible. My new favorite phrase from an earlier talk in this session is now tile deltas. We've paid attention to try to, or basically we've confronted that same problem, right? If you have an incoming resource with 1,000 tiles and 3 of them have changed, it's nice not to fire off 997 updates to the edit log. Right, and then what Lingo is doing is we've wired it up with an API framework. So the current state of development in the Arches QuerySets repo includes an optional integration with Django REST Framework that provides generic views, so you don't have to write your own get, post, and deletes. But I want to emphasize that this is optional. Because the underlying implementation is sort of conforming to the Django QuerySets API, you can use other API frameworks. If you want to try Django Ninja, you want to try a GraphQL client like Strawberry. We haven't prototyped those other integrations, but we're kind of relying on the fact that because we're using QuerySets and those clients use QuerySets, that should be more possible today than yesterday. All right. As I mentioned at the beginning, I wanted to acknowledge some important precedents for this work across the Arches community. That is an incredibly inaccessible font size, so I'm going to have to read this out loud. But in Arches project /Arches, we've got the resource report API powered by what's colloquially called the label-based graph. It also uses semantic keys to map tile data back to aliases. It concentrates on the retrieval use case. It has flags for selecting the representation you want. For instance, removing empty nodes or asking for string data in a specific language. In Arches project /Arches, we've also got the relational views, which is a SQL-based approach designed for ETL use cases. It supports full CRUD. We even have projects that have linked it to Django models, unmanaged Django models, so that they can also facilitate integrating with Django REST Framework, for instance. Some aspects of this implementation involve that it doesn't use the validation logic in the rest of Arches, so there's a potential for drift there. And it does involve, by design, involves direct database operations. So, it generates views and triggers. There's also open questions about the future for optimizing performance and also compatibility with any future data types. And we have a number of experts in the room at Flax and Teal about the Arches ORM that I'm hoping to speak to this week, who should be able to share their knowledge about their solution for a intersecting set of problems here. But thanks to the walkthrough that I was able to have with them earlier, or I guess late last year, I understand that it's solving server-side access to Pythonic resource models after fetching them from the database. So based on, my other favorite term from earlier today, ELT, there's a sort of load phase that comes first and then a transformation afterward into Pythonic structures. And it's also explicitly designed to wrap other backends besides Postgres, for instance, Spatial-like. And if I got any of that wrong, please correct me. Okay, cool. But I went into that in excruciating detail just to point out that there are many people in the room that have been working on this class of problems. Okay, so why did we sort of look at the Django QuerySets way of doing things? One of the things that they offer is that they're lazy and they're chainable. So they allow you to program in a more declarative way. So I'm not ready to, basically you can sort of encapsulate a bit of application logic and then leave it undetermined whether or not the caller of your code is ready to execute a query or not. Just leave it lazy and let someone else down the chain run the query when they want to run their query. This avoids the problem you see in a lot of code bases that have a mixture of sync and async code, where they're constantly kind of paying the toll to go across the toll bridge, right? They can't keep all of their code async. They're constantly, well, I have to run some of this sync, so I'm going to eagerly evaluate it. Now I'm going to try to do some of it async, and I have to run back. The idea is that if you leave as much of it as lazy as possible, you're not paying that cost of frequent and eager evaluation. It has built-in caching. You don't have to re-implement caches. Django models already have caches. Query sets are cached, and they also include caches for any related objects. It's debuggable because it's there's IDE tooling for it. I like to think of it as interoperable because, as I just mentioned, I'm optimistic about integration with other API frameworks because I'm conforming to a standard Django interface. So it kind of unlocks interoperability with the rest of the package ecosystem for Django. Arches, I don't know whether to say Django is becoming like Arches or Arches is becoming like Django, but similar to Arches, in the Django community, there's this push to sort of prototype new features in third-party applications and being more conservative about what gets merged into core. So what that means is a lot of the really recent cool stuff in Django is in the package ecosystem. So it behooves us to try to unlock some of that if we can by making Arches data kind of conform to the same interface. I'd also say it's relatively onboardable because it hopefully will lessen the learning curve for developers that you might bring on board that have a Django background. And it also kind of forces you to express your business logic in models instead of in your views. So fatter models, thinner views. Leave your views responsible for doing view things like parsing a keyword instead of doing business logic. Okay. That would be a graphical version of the flow I was just referring to. I'm going to focus on the API use case and just leave migrations and notebooks alone. But this is the division of labor that we're using in Lingo. Each layer here delegates to the next layer. So if your URL is the route, it invokes a view. The view invokes a serializer. That's the layer where you define your API representation, right? What should be in the body of my post? What's read-only? That sort of thing. All that information gets delegated to a query set. That's what fetches your model instance. That has other methods hanging off of it that you can call at will, and then you return a response. If I sort of break this out into another dimension, obviously it's ultimately a serializer that returns a response, or perhaps speaking a little bit more precisely, it's the view that returns a response. The reason I'm breaking this out is just to show you by clearly delineating what a view should do, instead of that Arches for Science view that's doing 4 different things, it's easier to reason about what you need to override, right? Do I want to inherit from the serializer that ships with Arches query sets and add my special sauce? Or do I really just need to write a different kind of query set? Or do I need to write my own view? It's more clear where you need to intervene to add customization. Here's an example from the Lingo project. We just wrote some routes that are relatively generic. This can all be done to your taste. Like you could rip the app name out of the route if that's not useful. We just left it in here to distinguish it from the core Arches API. But notice the route components are named slugs, like the named slug of the graph. And for instance, this third route is a partial representation of a resource that takes an arbitrary node group alias. So you could request a representation of a resource from kind of anywhere in that node group tree from that point down. Another project has a different set of routes, but talks to the same generic views. So the point is here that the vector for customization here is you can write whatever routes you want and then wire them up to the same thing you imported from Arches QuerySets. Then the next layer would be the view. This is what our views look like in Lingo right now. You import all the stuff you need, and then these are the only views we are using in Lingo. They're written in the kind of declarative style where you just say what the permission level is. You say which serializer you're going to invoke. It's just sort of defining the handoff to the next layer, right? But of course, if you need more functionality, they're just hooks for performing additional functionality. So if your creates need to perform side effects, you can implement perform create, etc. If you need to invoke, if you have a special view that needs to invoke a special query set, you just override get query set. It's at sort of each layer that hands off to the next layer, you've got a clear kind of point of customization. Now the serializer would be the next layer. Lingo almost doesn't need a custom serializer. We've left one in just kind of as an experiment, but we experimented with implementing validation against incoming tile data at this layer until we realized we kind of just wanted to be using tile functions to maintain compatibility with the rest of Arches, like the Arches resource editor. So we're basically at the point where we could just delete all of this. But I left in this slide to show you that if you didn't care about the resource editor, maybe you haven't even exposed that page in your application because you have a pure view front end or something, this would be a layer where you could validate incoming data. And like the previous slide, there are clear hooks for, do I need special CRUD operations? In your update method, just call super update and perform more side effects. This is what the payload looks like right now. This is still alpha software, so we might change the shape of this response slightly, but you have a sort of shape of a resource where there are, A kind of floated to the top here, but if I scroll to the bottom, you have the sort of generic columns on the resource instance table, like created time and legacy ID and principal user. But all the meat of the data is up here in this separate namespace for node values. So we've got the version node group, which is empty. A node group with data in it is the statement node group. And then we've got information about the tiles, aliased under human readable node names instead of under, identifiers like these other ones you see on the screen. If time permits here, I could probably show you the world's simplest live demo. Let me scroll to the left. Bring this out. You know what? My vision is not going to be good enough to read that from here. This room is a little bit longer than I anticipated. I guess I could boost this. Okay, well, regrettably, catch me on Wednesday if you want to see a live demo. But anyway, this is the browsable API that ships with Django REST Framework, which allows you to preview a response without having to view a front end. And then, for instance, you can edit this JSON and post it back. So notice I can operate on an arbitrary number of tiles here and fiddle with the node values and post it back. And I'll have avoided having to orchestrate a complicated series of operations on a number of tiles by just making one alteration to a JSON payload. Let's go back to my other view. Okay, cool. Okay, querying. We also wanted to expose an interface for just running queries. In part because, one of the explicit goals here is to make it easier to filter large sets of resources and tiles according to node data, like node data queries. Once again, the disclaimer, don't memorize the names of these functions. This is still alpha software and we're still tinkering with names and interfaces, removing keystrokes where it makes sense, for instance. But on line 1 here, the basic idea is that you can request a set of resources. For instance, you can ask, give me something shaped like a scheme is what line 1 does. And then line 2 filters the schemes according to a node value. And here it's a fuzzy match using starts with. So I'm filtering for the AAT entries scheme. with the double underscore starts with function. These are also customizable. You can write your own lookups that compile to SQL. And in fact, the Arches QuerySets repo has some prototypes of like localized lookups so that you could do starts with in any language or case insensitive starts with in any language. So yeah, and they're chainable after each other. So double underscore my filter, double underscore your filter, et cetera. And then because concepts and schemes in Lingo are the two chief models on line 3, I'm asking for things that are shaped like, or I'm asking for resources to be shaped like concepts. And then I'm filtering on, give me concepts that belong to the scheme I just fetched. And then if I print them out, you know, et voila, you can sort of get the sort of, you notice I'm in, let's see, what am I dotting into? Dot statement content. So underneath the representation of the concept, you know, there's my node data aliased under statement content. Okay, I promised I would end with status. This is still in alpha. We're spinning up tests and docs. Regrettably, there is a lack of both if you were to visit the repo right this minute, but I think that's something I can start remediating this week. The goal is to have a beta compatible with both 7.6 and 8 by June 15th. And then after some usability feedback, we can drop support for Arches 7.6 and issue a real 1.0. So this is kind of what I've covered so far. The goal is to push tile transformations out of projects, to let both front-end and back-end code speak in named node and node group aliases. I could pause here and mention that that's what we're doing in a few projects right now, is letting the front-end dynamically build a form based on requesting a representation like this, and then using that information to build form fields. We're kind of integrating tightly with the work in Arches Component Lab, for instance, to develop widgets that can exchange these slimmer formats, for instance, just a single string value instead of an entire localized string blob. And as I already mentioned, the idea here is to reduce surface for omissions so that fewer gotchas have to be discovered project to project. Interoperability and yeah, we're developing it in a way that's API framework agnostic. So all the code supporting DRF is in its own submodule. To clarify, you could just delete it. That's it. Thank you. Happy to take questions.
So who would like to start? Oh, we've got, sure, that's the, oh, sorry, Gil.
I think I speak for the entire room when I say yes, yes, yes. I can't wait to never hard code a node ID into tile data ever again. What a dream. Yeah, thank you, seriously. I can't understand, I can't overstate like how needed this is, not just like for everyday development, but also like, as you mentioned, like to get new developers in. I mean, it's just such a hurdle to have to learn the generic schema in order to do basic, you know, Django-esque operations. So this is so critical. One question I have is there a roadmap to do like data type specific, I don't know what the word is, but like, for example, like starts with, like double underscore starts with. Is that a data type specific thing? Is that generic to like the value that it is in Postgres? Like, can you shed more light on that, I guess? Apologize, the question's kind of
yeah, no, that's something we've talked about. It hasn't been tackled yet, but that's I mean, it's funny because we have this overlap between Arches data types and Postgres data types. So clearly the lookup that I wrote only works on strings. So I have no trouble forecasting that if your lookup works with a Postgres data type, it'll work just like that string lookup. If the question is, I want to look up, but I want this to throw an error if I use it against concept instead of resource instance or whatever, that would be perhaps a little bit more magic, but shouldn't be insurmountable either. But yes, no, the idea is I mean, for instance, looking at by resource instance, like there are a number of ways you might want to look up a resource instance, by ID, ontology property, like, and so getting all of those defined would be the next chunk of art. Yeah.
I can comment on that just quickly. I imagine part of what you're kind of alluding to there, Galen. These things like using intersects for geospatial data. There's some work that needs to be done prior to that though as well here, I think. because when we talk about Postgres data types, we're actually talking about, like, I mean, I think, you know, we need to sort of transform the JSON, the GeoJSON in this case, right, into a geometry in order to facilitate those things. But I think that would be, I think it's almost necessary that we want to get there.
I mean, I'm thinking that, I'm thinking resource instance data type, you know, I just everything.
Yeah.
No one else?
I had a question about resource validation. So this is something that we need, so to be able to basically say, is this resource valid instead of is this tile group of this card valid? Will this help with that as well, or is it on the roadmap?
Yeah, I mean, if I don't have the live demo up right now, but catch me later in the week, I'll show you, you know, if you submit invalid, so I had a resource JSON, a resource described as JSON. If I'd put invalid data anywhere, I would get back associated with the specific node and node groups, like the list of errors. And that's running both like tile validation, like it's trying to dog food as much as possible the existing Arch's validation logic. Yeah.
Will this also work when it's just missing? So one of
Yeah.
the things is when just a whole group is missing, it will say you need to fill this in.
Well, it depends on how you've defined your cards and graphs. Like if you've defined the node configuration, it's reading from all the graph configuration information. So if you've defined the node as required, that will be an error. If I don't think node groups are required in Arches. There's not a way to require a node group.
If you are saying insert a tile where there's no parent tile, like
No. What I'm basically saying currently, when you say this card needs to be filled, this cards need to be filled, you can just save it just fine. It never says like, user, can you please fill in this information? Because it's required. And that's quite a big gotcha for most of the customers, because they go like, why can I save a record which is invalid? But because it doesn't have invalid cards, because nothing has been filled in, it never throws an error.
I mean, I think just to expand on, sorry, but just to expand on that, because I know exactly the issue you're talking about, there's a slightly conceptual challenge that's for when the first tile is saved, let's say, within the editor, then the resource has to be created. But at that stage, it will only have one tile, so if you have any rules that aren't for that specific tile, then the resource could never be created. But I think at some point there was a suggestion of putting it into a draft state and leveraging the new lifecycle, because then what you could do is say that you've a validation rule on translating from a draft state to a complete state, which I guess you could then apply your rules on. Is that sorry, I'm inferring a bunch of things that aren't actually part of the code I'm working on, so carry on.
No, I think your characterization of life cycle and how it can be used there.
Yeah. I have one question.
Yeah.
Because I always do. Do you reflect, or is there an intention to reflect the graph hierarchy in the in kind of nested pseudo objects, or is it a flat alias?
Reflected.
It is right.
It's nested, yeah.
Nice.
And to give sort of natural dot access into like, you know, dot named parent node group, you know, and dot children, et cetera, yeah.
Excellent.
Yep.
And this works at both the model and the node group level.
Okay, nice.
Yeah, it tries to flatten that distinction, so the resource is just a top node group.
Yeah.
Yeah.
Okay. Thank you very much.
One more question. I'm curious, what is, it's sort of a two-part question. What is the limit of what we can do? Oh, sorry, buzzing. So like, you know, all the things you can do with Django regular query sets, what is the limit of Arch's query sets in comparison to that? And also kind of on the other side of the coin, what is the limit of what we can do in terms of accessing ArcGIS data through this medium?
Great question. That's actually probably a great section for a README to clarify. It's going to require a little bit of research to find out, but I think I'm trying to conform to the QuerySets API, so I haven't implemented everything. Like I don't have a wrapper for get or create that does those magic 2 actions, but I don't see any reason someone couldn't implement that someday. I guess limitations, I said queries have to be schema aware, so part of the way that, I mean, that first call you saw that said like, give me schemes. That does database queries eagerly in a way that doesn't, ordinarily you'd like your queries to stay lazy. So I'm looking into ways to try to remove those eager operations to keep everything lazy. And we might get there, but this current alpha, like you saw me do like a couple of steps to fetch the concepts for a scheme, and there just probably is a nicer way to do that kind of as a one-shot operation.
Okay, great stuff. Thank you very much.
Yeah, thanks.
Brilliant.